This will be a brief demonstration cut of the Forest Manufacturing Model 2054R vertical blade traveling table bandsaw for cutting rolls, hence the R in the name. I have a following video that goes into all the features of this machine. This video is specific to making a test cut on this material. Material I have to work with today is used in thermoforming. It is a very thin sheet material. It is wound on a cardboard core, and I don't know, ABS, maybe ABS, I'm not sure the exact material, but it's a thin sheet, hard wound on a hard core. So it's going to behave like a solid piece of plastic. It's about 14-inch diameter. The blade I have to work with right now is a 1-inch wide, 3 tooth per inch hook tooth style blade. I'm running a fast blade speed of 3,000 feet per minute. I have a 2 horsepower motor on here, which ought to be adequate for this. The concern is going to be, can I get a good clean cut without melting or fusing the material? Thermoforming material is meant to soften at a relatively low temperature. Bandsaws tend to make a little heat as they cut, so we might have a conflict there. Gonna find out. So the roll cutting machines, actually I don't like the way this is, oh, that's heavy. I can't even roll this bar, I can't spin this around, but the advantage of the roll cutting machine is I've had this V-shaped cradle made with roller conveyor, so it's actually pretty easy to reposition the workpiece for cuts. I also have this workpiece positioning fence. So it's got a gear rack, synchronized drive, moves back and forth nicely. This machine hadn't been painted yet, but there will be a inch scale on the table surface with a pointer on the fence. So if you want to cut off, say, 4 inches of material, you just set the pointer at 4. We also have available an electronic digital readout, which mounts right here. Gives you 3 decimal inch precision, but it's a little overkill for an application like this, unless you're just really trying to get down to 5,000. And that's a 5,000 is a big ask on a bandsaw. We hit it sometimes, but it's a big ask. So you can either set the workpiece positioning fence at 4 inches, run the workpiece in the fence, or you can just go ahead and push the workpiece up against the fence. I'll point out this this workpiece, the roll has slid a bit, so it's not nice and tightly coiled. But you can then use the fence to position the workpiece. I'm going to take off a relatively small bite here, just to prove the concept. And then this would probably stay in place, but it does roll really easily, so I'm going to go ahead and lock it in with some magnets. What you can do here, just use these magnets and push up against the steel frame of the conveyor to discourage the workpiece from moving around. So I'm going to feed this in manually. This is a manual reverse table. I'm going to take this relatively slow to see if I can get a quality cut. It's more important that I get a quality cut than a fast cut at this stage, because if I can't get a good quality cut, nobody cares how fast I do it. But if I go too slow, that might lead to this stuff melting instead of cutting nicely. So, see what we get. I have not cut this material before, at least not like this, so we're all going to find out together. There it is. Yeah, it's taking some force to get it to feed. It's cutting like a solid block of material. Damn. I should have lowered the upper blade guide before I did this. We're about at midpoint now. Okay, we're through. I'm going to pull this workpiece out, but I'm then going to reposition and make a second cut, because this will give me a good reference surface. And I'll have a good reference surface. I'll make a second cut. I'll know how this stuff's heavy. Here's what we got for the first one. That's actually a nice cut. It chipped a little bit on the cut edge here. It chipped a little bit. But there's no fusion. It's unwinding just fine. So I'm gonna go ahead and make a second cut on this same workpiece. Then I'll have a cut piece, 4 inches wide or so, where both surfaces came off the bandsaw. Well, feed the workpiece in. Okay. Second verse, same as the first. That cut skewed just a little bit. I was a little too aggressive with my feed speed. I think that cut skewed, went off line just a little bit. I'll have to do a third cut, even slower. Because that was not a perfect cut. So we are getting a little bit, it's trying to chip out on the cut edge. When the blade exits the workpiece, it's chipping a little bit instead of cutting. So I think if I was cutting just this, I would use a very, very fine tooth blade. But because in the body here, this material acts like a solid piece of plastic, if I tried to use a fine tooth blade to cut this, it would never get through. And yeah, that cut went a little off true. So I'm gonna try one more cut with a slower feed speed. I've gotten a little aggressive there. Yeah, definitely not a straight cut that last pass. But that could very well be down to me being overly aggressive with my feed speed. popping you're hearing is, I believe, the material ripping out instead of cutting nicely. Those last few pieces of material at the edge, I believe those are ripping out instead of cutting nicely. We're in the center core now. Just a second, be right with you. I'm video recording. I'll work around it. It's okay. It's cool. Yeah, we're off by about a 1/4 inch. Okay, so this may not be the answer. Take a look at the cut piece again. Again, even with a very gentle feed speed, the blade did not track exactly straight on this stuff. And we got a lot of chipping out here. This is where the blade's exiting the workpiece on the back side. Yeah, this may not be the answer for this application. But if you have any questions or like to discuss a specific application, please feel free to call or email us at Forest Manufacturing. Thank you for your time.